Okay, we want to look at triglyceride synthesis, right? We have seen that it is one of the subclasses of what? Lipids. Now, we obtain triglycerides from diet. So even after digestion where they are broken down into, let's say, monoacyl glycerol, free fatty acids. In the epithelial cells of the intestine, right? Epithelial cells of the intestine. They are what? These glycerol and free fatty acids are really what combined to form triglycerides and then are absorbed, complex with chylomicrons, and then they add up apoprotein and then they are absorbed into lymph. Now, we want to look at how the body is able to what? Synthesize its own fatty acid. So most of the body's tissues can do that, but special mentions made of the intestines, the liver, and then adipose tissue. So those sites are very critical to the synthesis of fatty acids, of triglycerides. Now, there are two major pathways, right? There are two major ways by which the body synthesizes fatty acids. One is the monoacyl glycerol pathway. So let's take a look at this monoacyl glycerol pathway. Now, this occurs in the intestine, and it makes up about 85% of all the triglyceride synthesis within the intestine. Now, the epithelium, right? The synthesis is limited to the epithelium of what? The triglyceride, of the intestine. So that one, epithelial cells, and it is in association with the smooth endoplasmic reticulum. Now, what happens is that after you have taken in a lipid-containing food, all the lipases have acted on them. The triglycerol content, I've already mentioned that you can get free fatty acids, you can get glycerol, and then I also made mention of monoacyl glycerol, right? Monoacyl glycerol or monoglycerides. Now, this is what is important to this pathway. Now, a triglyceride is just a one word. Okay, so triglyceride, right, is made up of three fatty acids. Three fatty acids plus what? Glycerol. Now, now this glycerol, right, is propan 1, 2, 3 try also. Let's try and see if we can get 1, 2, 3, right? And then we have OH, and then OH. So you can have 1, 2, you can have this, you can have this. Now, the triglyceride is essentially an ester. So esterification is a reaction between an acid, right? An organic acid and an alcohol. So these hydrogens will be replaced with what? So one fatty acid will be here. One fatty acid will also be here. And then another fatty acid will be here. So that will give us the acyl glycerol or the triglyceride. Now, this monoacyl glycerol is already carrying one fatty acid. So there's a need to add just two. Just to add 2. So what do we do? Let's take this, clean this, and then okay. Okay, so this monoacyl glycerol has one fatty acid. So the first thing that will happen is that this monoacyl glycerol would now react with one fatty acid. Remember that the fatty acid needs to be what? Activated. So it is joined to what? Coenzyme A, right? So that's the first thing that is going to what? Going to happen. And then the two of them, when they react, they are going to produce diacylglycerol. Now you wonder where this other fatty acid will be what? Will be added. Now this monoacyl glycerol is the acyl groups on the second carbon, so it's actually 2 monoacyl glycerol. Now after this reaction, the diacyl glycerol form can either be 1,2 diacyl glycerol or 2,3 diacyl glycerol. You see also that we can have a mixture of what? The two. We can have a mixture of what? The two. So either the fatty acid that we are going to add here should go to the first OH, or it should go to what? The third what? OH. Okay. So what enzyme is going to work over here? The name of the enzyme is the acyl-CoA monoacyl glycerol transferase. So this is the enzyme that is going to carry what? The fatty acid. You leave the CoA out, and then it will carry the fatty acid and then add it up towards the monoacyl glycerol. Okay, so that is the enzyme over there. Now, what goes on next? Now that you have the acyl glycerol, your dream is what? To synthesize what? A triacylglycerol, right? So what we are going to do is that the diacyl glycerol also reacts with what? Another fatty acid, or most of the time, right? A fatty acyl. Let me keep it this way so that. Now, the enzyme here, they shorten it as DGAT1, right? That is diacylglycerol, right? Then you add the acyl transferase. Yes, and then when you're able to transfer the fatty acyl unit, then we end up with what? Triacylglycerol. Triacylglycerol. So our acyl glycerol, right? After the action of the pancreatic lipases on your triglyceride that you obtain from diet, and then it formed the monoacyl glycerol. Then the intestines can pick this up and then go through the process that we have just illustrated, and then will form what? Triacylglycerol. So we have made mention of the enzyme here, acyl-CoA monoacyl glycerol transferase, and then the DGAT1, that is diacylglycerol acyl transferase. Now let's look at the second pathway. Now this second pathway is called the glycerol 3 phosphates, glycerol 3-phosphate pathway. Okay, so the essential thing is that for the synthesis, we need glycerol 3-phosphate, right? Now, there are two ways by which we can obtain this. One is we getting these substrates from what? Glycerol. Or two, we obtaining it from what? Dihydroxyacetone what? Phosphate. So this is one of the intermediates in glycolysis. When you split fructose 1,6 bisphosphate, and then you end up with DHAP and then the glyceraldehyde. Yes, so DHAP is over here. Now, this glycerol is what? Acted on. Okay, let me take this one. Glycerol kinase. What does the glycerol kinase do? It takes a phosphate group from ATP. Takes a phosphate group from ATP and then adds that phosphate group to what? Glycerol to form your glycerol 3-phosphate. Glycerol 3-phosphate. Now, because this enzyme glycerol kinase is not in the adipose tissue, this particular pathway is not pursued over there. And so now let's look at DHAP. That is more prominent in what? Adipose tissue. Adipose tissue. Now, your DHAP is acted on by the enzyme glycerol 3-phosphate dehydrogenase. So this enzyme acts on DHAP and then by giving to NADHs over there, then it forms what? Glycerol 3-phosphate. Glycerol 3-phosphate. So that is what you obtain from that. Now that you have synthesized glycerol 3-phosphate, this one is, so this one, we said adipose tissue doesn't have glycerol kinase, right? So mostly you have this occurring in the liver. And then this one is, this can also occur in the liver, but it is more prominent in what? Adipose tissue. So now that you have glycerol 3-phosphate on both ends, then you can now what? Start the actual synthesis. So let's go. You have glycerol, let me change. You have glycerol 3-phosphate plus a fatty acyl CoA. Fatty acyl CoA. Now the two of them are going to react. The two of them will react, and then you give us what you call your mono acyl glycerol 3-phosphate. Elsewhere, you will see the name lysophosphatidic acid. Lysophosphatidic acid. The enzyme here is glycerol 3-phosphate acyl transferase. Acyl transferase. So either monoacyl glycerol 3-phosphate or lysophosphatidic acid. Then this lysophosphatidic acid reacts with what? Another fatty acyl CoA. Just explain this. So it reacts with another fatty acyl, fatty acyl CoA. Let's keep it like that. And then this time around, you get what you call the 1,2-diacyl glycerol phosphate. 1,2-diacyl glycerol phosphate. Now, this is also referred to as phosphatidic acid. Phosphatidic acid. Okay. Now, you know that we are forming triacylglycerol or triglyceride, and there is no phosphate group in that. So in this next step, they are going to do what? The removal of a phosphate group. So there is a hydrolysis that takes off what? The phosphate group. So let's move on. There's hydrolysis. So we have water, right? Water, then you end up with what you call 1,2-diacyl glycerol. 1,2-diacyl glycerol. And then the enzyme that we have over here is the phosphatidic acid phosphohydrolase. Phosphatidic acid phosphohydrolase. And that's going to give us what? The 1,2-diacyl glycerol. Then this 1,2-diacyl glycerol now reacts with a final fatty acyl CoA. And then you have the diacyl glycerol acyl transferase over there, same as the one in the acyl glycerol pathway that we talk about. And then it will yield the triacyl glycerol or triglyceride. Okay, so that is the two pathways that lead to the synthesis of triacyl glycerol. We've made mention of the fact that this second pathway requires what? Glycerol 3-phosphate, right? And then we either go through two ways to be able to form the glycerol 3-phosphate. Either you start with glycerol, and then glycerol kinase acts on glycerol by giving it a phosphate group from ATP to form glycerol 3-phosphate. Then you either use DHAP, acted on by glycerol 3-phosphate dehydrogenase. Right? You have glycerol 3-phosphate forming, and then the main reaction starts on and on and on, and then you form triacyl glycerol.